All right, so for people who need help with question 10, we need to read the question. Now, most people were fine with question 10, part A, B, and C. It was just looking at the formula and substituting it in. So I'll read it quickly. And then most people where they had trouble was D, E, and F. So it says, to find the density of a solid or liquid, we divide its mass by its volume. So question 10, we divide its mass by its volume. So D equals M over V. If the mass is in kilograms and the volume is in cubic meters, the density will be kilograms per cubic meters. So that part is just saying this is the measurement we're going to use. It just depends on what measurements you use to start with to get your final measurement for density, and it changes. If the mass is in grams and the volume in cubic meters, then the density will be grams per cubic meter. So then the first part says, find the density of aluminium if 100 cubic centimeters has a mass of 270 grams. So for aluminium, we're saying mass and volume. So which one's the mass? 100. So we've got 100 cubic centimeters. That's that important information you would have highlighted. 270 grams is the other important information you would have highlighted. Which one's mass and which one's volume? Good. So we need to know that pretty much anything to the power of 3 is usually volume, okay? And mass is using grams or kilograms, etc. So this one equals M, this one equals V. Once we've defined that, and you can put it in your question, that way you actually know what you're doing, the question becomes quite easy, because to find the density, we just say D equals 270 over 100. So our density is 2.7. What measurement was the mass in? The mass, grams per cubic centimeters. So the way you know which measurement it is that it's always in the same order as the fraction. So whatever measurement the 270 is, that's your first one. Whatever measurement your 100 is, that's your second one. So grams per cubic centimeters. And that's what that second sentence in the question is saying. Is everyone okay for that? B and C are exactly the same. Does anyone need me to go through B and C? D is where everybody got stuck, which is fine. I got stuck with it yesterday as well, because you have to read it really well, and they've given you extra information which you don't actually need to use. You can pretty much disregard one major bit of information in this story, okay? So again, it's about reading the story and making sense of it before you try and answer the maths question. In applications, you need to work out what the application actually means. If you can do that, the maths becomes a lot easier. So the density of seawater increases with depth due to the pressure of the water above. Find the density of seawater in grams per cubic centimetre. Now, that's saying seawater density from the top to the bottom gets more dense because of the water above it. It's still using that same formula. It hasn't given you a new formula. It's still using that same formula, okay? You don't have to change the formula. It will tell you if you have to change the formula. So what it's saying is we're looking at seawater and we're finding the density of it at different distances. So the first part says just below the surface where 5 centimetres has a mass of 5.14 grams. So again, we're just going D equals, we know our formula is mass over volume. So just look at the question. Mass is 5.141. Volume is 5 cubic centimetres. You don't have to do anything about that distance below. It's just telling you at the surface, the density is that much. So then we get our answer. Sorry, has anyone got an answer for that? I don't have a calculator on me. Could someone chuck that in their calculator and find an answer for me? Yeah, Emily? 1.0282. And because it is in cubic centimetres so grams per cubic centimetres. So it's exactly the same as those other questions. It's just looking at seawater. Seawater is the density. Does that make sense? Okay, E is where people then got confused, but it's actually still the same thing. It then tells you 1,000 metres, so a depth of 1,000 metres, where 5 cubic centimetres has a mass of 5.164. So what's the difference between D and E? For D, the volume was 5 cubic centimetres and the mass was 161. What's the difference between the two? The volume's the same. The mass has changed. So the story is telling you the mass changes when you go from the surface to 1,000 metres below. This is what the new mass is. You don't have to do anything with that 1,000. It's just asking you to find the density of the salt water at that level, given those two bits of information. So how do you think we find the density? Emily? Exactly. We just do exactly the same thing with that formula. We don't have to do anything about the 1,000 because it's just telling you this is just a place where the salt water is. It's actually just part of the story. And then we find our answer for that as well. Should be 1 point something, something, something. Does that make sense? Does that make sense to people? Yeah? And the next one's the same. You don't have to worry about the 10,000 metres because it's telling you what the mass and the volume is, and you can work out the density as long as you know the mass and the volume. So when you're looking at these sort of questions, look at the formula and go, what information do I need? They're the bits I need to pull out to actually answer it. Sometimes we give you extra information to confuse you a little bit. Okay? Does anyone need me to go through 11? I know there are a few people who had trouble with 11. Yeah? All right, so for question 11, again, if you have done question 11, you got it all right, just keep working through that worksheet. For question 11, it says, if you deposit P dollars, now we're going to be using this formula in maths this year and next year. It's actually done in year 12 as well. So it's important that you kind of understand what this is. This is a compound interest formula. So if you deposit P dollars in a bank account that earns interest at X% per annum, compounded annually, the amount in the account after T years will be A dollars. So we need to work out what all these letters are. Remember how I said we try and define those letters? So we need to know what A is, what P is, what X is, and what T is. And then we should be able to work out what information we need from the story. All right? So if you deposit P dollars in a bank account, so what does P represent? What measurement are we using? Dollars. Okay, so we know it's dollars and it's a deposit. It's an amount of money we put in. The deposit in dollars is P. The official term is principal, if you're having trouble with that, okay? Then if you have, earns interest at X% per annum. So what's X? X is a percent and it's the interest. Okay, so we define those two. Then it says compounded annually, the amount in the account after T years. So what's T represent? Years or time in years. Will be A dollars. So A is your final amount in dollars. Okay, so we've got an amount we put into the bank. We've got an interest rate the bank charges. We've got time which the money's there. And then we've got the final amount. Okay, the interest is like you accumulate. Interest is you get extra money, and we'll be talking about finance a lot this year. Okay, so find the amount in the account after 5 years. If $300 is deposited at 10%, so $300 at 10% interest rate per annum compounded annually at 5 years. So we've got that information. So $300 is your deposit, the 10% is your interest, and the 5 years is your time. And once you define those variables, what do? Put it into the equation. So all we need to do is say A equals P 1 plus x over 100 to the power of t. So instead we put the letters in, sorry, the numbers in for the pronumerals. 300, 1 plus 10 over 100 to the power of 5, because it's 5 years. And we get our amount, which someone should be able to tell me. I think it's like 583? 483. And how many cents? So 1 5. Okay, one big thing for rounding. Money, we always round to 2 decimal places, always. And they're not going to ask you, they're going to expect it, okay? And in your WACE exam, if you don't, you lose a mark straight away. And you lose a mark every single page you do it wrong. So we will be doing that in your exams as well to get you used to that. So anytime it's money, you round to 2 decimal places. So to the single cent, 99 cents, 98 cents, 15 cents, things like that. We'll talk about that when we get to finance a bit more, okay? I'm not going to do B and C because they're exactly the same, just different numbers. Does anyone need me to look at question 12? I think mainly question 12 is just about using your calculator. So knowing how to do the square root sign, that's pretty much the main, and the pi sign, so it's just a practice thing. So everyone good with the homework now? Is everyone good if we kind of move on from formula a little bit? Yeah? All right. How have you gone with that worksheet? Okay. I'm just going to turn this off for a second.